The general implementation of HDTV broadcasting and digital cinema implies a very high-quality film's argentic remastering. To address this constraint and consolidate its leadership position in the field of film archives restoration, Laboratoires Neyrac Films, LNF, has launched the following two research projects. Nitroscan, subsidized by the French National Centre of Cinematography, CNC, is a plan of building of a specific scanner to digitize films archive. Its particularity lies in the fact that it scans directly the original nitrate without having to deal with safety intermediate, as it is usually the case today. Improvement of quality, wet scan of the original, and a reduction of the expenses, operations are simplified, are the two main expected benefits of this technology. Resonances is a project dealing with digital sound restoration, subsidized by ANR, Agence Nationale pour la Recherche, and led by the University of La Rochelle in partnership with the CMM, École des Mines, Center of Mathematical Morphology of the Paris School of Mines, LNF and CNC. This project has the very specificity to treat the sound, i.e. the picture of the sound, graphically. Like Nitroscan, this technology will allow for quality improvement, whilst reducing the improvement cost of digitization, thanks to simplified operation. Cellulose nitrate was the first plastic invented by man. Its excellent mechanical properties and its flexibility allow it to be used in rolls. Since the birth of cinema in 1895 and up until the beginning of the 1950s, films were made on a nitrate cellulose basis. Unfortunately, nitrate-based films degrades inexorably by depolymerization. Decomposed cellulose nitrate is also highly exothermic and self-combusts with the release of hazardous gas emissions. After 1950, production and use of nitrate film stock were forbidden. Film archives throughout the world had to safeguard abandoned nitrate films, transferring them onto a safety base for access. The film basis shifted from nitrate to acetate, which has the great advantage of a low flammability at 430 degrees C. However, acetate film stock is also subject to a precocious decomposition, known as the vinegar syndrome. You can see on the picture the different states of the degradation, since 80s polyester film is used for prints and intermediates. To restore a film, one first have to make the film basis easy to manipulate. Films going through decomposition are dried in a desiccant containing silica gel which absorbs the water, thus stopping the acid emission through the absence of hydrogen. As for the brittle sticky films, they are humidified and made flexible in a desiccant, a mixture of the three solvents of nitrate and acetate bases. Thanks to these repairs, the negative becomes printable and can hence be moved and transported via the pins of a printing machine. Fragile or visible splices are mended or redone. Torn perforations or missing edges are reconstructed. Shrinkage is measured to coordinate it with the necessary adjustment on the printing machine. In the worst case, the frame may be torn and must be repaired. Once reconstructed and repaired, the original negative is graded, which means that a level of light is determined for each shot of the film. The film is then cleaned to eliminate the encrusted dust on its base. The next step is to proceed to its printing by immersion in order to eliminate the scratches. Depending on the quality of the repaired film basis, frames will be either transferred on a contact or a step printer. This is how the first intermediate film, called interpositive, is obtained. In the case of continuous printing by contact, the matte sides of the two films are placed one against the other, driven by a sprocket, and scrolled in front of limelight. This method is only possible if the print to be transferred does not have too much shrinkage, otherwise the sprocket could harm the film. Whilst this method is rapid, it remains limited to the material with few shrinkage. In optical step printing, the shrunk master is projected and enlarged on the new basis, frame by frame. The transport is not longer done by a sprocket, but by a pin, the space being set to the shrink of the original. This method can be used if perforations are not too damaged, and if the bit of play is not too important to guarantee a good stability. Otherwise, it might be necessary to move each picture manually with the help of an optical collimator. During the printing, the scratches that affect the original diffract the light of printing and provoke a shadow area on the copy. To eliminate this phenomenon, the printing is done by immersion in a product having the same index of refraction as the film basis. This process allows for the elimination of all scratches on the shiny side of the film basis. It can be equally efficient on the matte side of the basis if the image information is still present. The dupe positive is cleaned in order to eliminate dust. Then it is printed and processed. This is how the second intermediate film, called internegative, is obtained. The internegative is in turn graded in order to refine the photographic quality of each film shots. And then after cleaning, the internegative is printed, then developed to obtain the first restored positive print. The classical photochemical process described above implies a successive making of an interpositive, an internegative, and a positive print. In the digital way, the restored negative is no longer printed, but scanned to be converted into digital. For that, LNF developed a special scanner adapted to film archive characteristics. Thanks to Nitroscan, even the most fragile films can be scanned by immersion, including all formats from 16mm to 70mm without even being dependent on the use of perforations. It is hence no longer necessary to repair the damaged perforations before scanning a film. As the printer's machines, two kinds of scanners machines are existing, continuous and optical step. But often these scanners are not particularly adapted to the specific problems of old films. On the contrary, Nitroscan is designed on the 5 major film archive characteristics. 1. Deeply scratched elements. 2. Shrunken or warped elements. 3. Various or none perforations. 4. Fragile or brittle elements. 5. Substandard formats. The only efficient way known today to eliminate scratches is to use a total immersion system as already used in photochemical treatment when making copies. The perfectly linear transport of a warped film during the acquisition is risky, so we choose to scan frame by frame. Consequently, a glass plate system flattens the film during the time the film is exposed to a matrix captor. The operator chooses the reference algorithm which will be used on a frame spacing, a perforation, or a detail in the picture. Once the point of reference has been located, the advance of the film is managed for a theoretical image height of a given frame. The driving system has been devised to scan damaged films to avoid complex and long preliminary film repairs. As these unrepaired films can be extremely brittle and as their processing must be very supple, the rotation of the capstan uses a gradual speed. To limit stresses, supply and take-up reels are not equipped with tension arm or dancing rollers. The angular speeds are measured with encoder on the shafts of the feed, take-up and capstan. This allows adjusting the torque depending on the reel's diameter and the limitation imposed by the mechanic stress on the film. Nitroscan is designed to scan all gauges between 16mm and 70mm. Unwinding and winding film systems are adjustable on the level of the platters and guiding rollers. The files obtained by the scan are transferred on a server. From this storage, the data are available on workstations equipped with specialized restoration software. This specialized software allows to correct visible splices, tears, decomposition, dust, scratches, colorimetry, and stabilization and flickering. After restoration, the images are back on the server. From there, they can be directed towards the imager for the shooting operation in order to directly obtain the internegative and the restored print. Since 1930 and the advent of talking motion picture, the soundtrack of the motion picture is recorded on the photographic film emulsion, beside the picture, as a visible recording of the modulation. At the beginning, the modulation was recorded by making density variable, dV. Then density was made constant, and it is the variable area, VA, of the transparent zone that carried the modulation. Today, the analog soundtrack of the copies is still existing in variable area beside digital SRD, SDDS, and DTS. The simultaneous transfer of the picture and the sound on positive copies by means of the printing machine needs a negative sound master. Only positive optical sound can be read by the analogical projector's sensor. It is not possible to read a negative optical sound without noise in silences and harmonics distortions in high frequencies, which cause hisses and sibilants. Negative noise is caused by the predominantly transparent area in silence, which lets through an important bright flux, and as a result, an important background noise owed to the thermal agitation of the photoelectric cell, and the reading of the impurity of the support, grains, physical defects, and dusts. After printing, the positive silence area is colored black and stands in the light way, and then limits noise quantity corresponding to breath. The distortions of negative soundtrack are wanted. In fact, during the negative soundtrack recording, an overexposure is deliberately applied, swelling of peaks and filling of slack periods, to compensate for the inverse phenomenon of diffusion which occurs during printing positive sound, erasing the peaks and digging slack periods. The printing of an intermediate element is therefore necessary to read a negative optical sound and extract low-frequency modulation. Nowadays, digital sound restoration is processed after transforming the positive optical sound information into an electrical signal. However, algorithms of digital process have difficulties to discern real from parasite sound, i.e. the slam of a door from a defect caused by dust. The soundtrack can be damaged by scratches, because it is close to perforation or mold. Scan and digital graphic sound restoration. The defects which we have just evoked are visible. A long vertical scratch or a side mold could not be part of the initial sound. There is no need to know the sound equivalence of the image to treat it. Sequence of the chemical classic restoration and the classic digital restoration. With the Nitroscan way, the steps 1, 2, and 3 are deleted. The original is scanned and restored to obtain the internegative by shooting. With the Resonances way, the steps 2, 3, and 4 are deleted. This results in the following sequences for the Nitroscan and resonance systems. From the server, the following formats can then be offered: VOD, DVD, PAD, and JPEG 2000. Photographic or electronic preservation? That is the question. Let's go, 27 centuries. Photographic, 5 centuries. Electronic? If the choice is photographic, though, analog or digital shooting preservation, in 5 centuries the world and the men vision will still be analogical. Hence, in 5 centuries, whatever its degree of complexity, technology will always have to allow for the pickup of analogical pictures of the world and, even more so, of analogical pictures stored on films. It is less sure whether signs encoded today will be equally useful in future. They keep well what is humanly visible. Peter Adelstein, Image Permanence Institute of Rochester. Sound shooting preservation? Picture preservation solution is applicable for the sound because it is a picture too. Picture and sound shooting on one and the same photographic polyester support must occur in the same recording operation. Sound shooting should be both analogical and digital. Sites exist and differs. Analogical for mono or stereo versions, and digital for multi-channel versions. Of course, black and white selection and 35mm cinema copy can be made from the server. Digital production can also load their pictures directly on the server. LNF Eclair Group, Nitroscan Resonances, Christian Kant 2009-09-28. Thanks to Pathé for his collaboration and Misters Bourville and Jean Gabin for their exceptional participation.